Hello, this is Rich. In this task, we're going to actually add our own custom game logic. This is where we're going to decide where the entities in a certain radius need to be for them to be affected by our explosion. We can do this right in the update function. It's a perfect place. So every frame, we're going to check what kind of entities are within our proximity. And if they are, we're going to add a physics impulse. We're going to add a boom, an impulse right to all the entities that are in the area and do some massive damage, actually enough to kill them. So let's get started. So first thing we need to do is we need to make sure our entity exists. So we'll go ahead and do that. Get entity. So we're going to make sure that the only entity actually exists. I'm going to store that in I entity p ent. And then we're going to check if p ent. We want to always make sure we check for null. Okay, so if our entity exists, what are we going to do? Well, we're going to tell the entity system to run a proximity check to get all of the entities that are within a certain area, kind of like a radius. So if our P entity is in a certain position, it's going to get, let's say, a radius of 10 meters around our proximity mine and say, hey, entities, are you within radius? Let's go ahead and do that. Go ahead and get the global environment, which is where we can get a pointer to any system in CryEngine. We're going to get the entity system, so P entity system. And we're going to run a query proximity. Now this will gather all entities that are within a certain proximity query. And it takes a proximity query that we want. So S entity proximity query. We're going to fill some parameters in here. We're going to take the bounding box. This is the area, the actual place, the area that we want to test if there's entities inside of. And this is an AABB. The bounding box, okay? So we're going to create an AABB, and it has a beautiful constructor that makes creating bounding boxes super easy. And what we'll have here is a point, so a vector3 position, an X, Y, Z position, and then a radius around. Well, this is beautiful. We'll take our entity's position, so the place of where the mine is, right? So get world position of our entity, and then we'll take a radius of, let's say, 5. So 5 meters anywhere around our entity. We'll take the query, we'll fill in some more. Count is an out parameter. It will be filled with how many entities are in our radius by the query proximity function. So we don't need to fill that at all. That will be an out parameter. The entity flags. We could specify different entity flags, which is a filter, meaning if the entity that's inside of the proximity doesn't have that specific flag that you're looking for, it'll just ignore it. But we want every entity. We don't want to specify any flags. We're interested in every entity there. Now, P entities is a pointer to a pointer, which is a list of all the entity pointers that are inside of our proximity. That's an out parameter. We don't fill that in. Now, P entity class is interesting. We can actually, it's a filter, and we can actually tell the proximity query, hey, we're only interested in this type of entity class. So let's say you only want to look for other proximity mines. Well, we can get the proximity mine class, and it would only query if there's proximity mines. But we don't want that. We're interested in everything, so we'll assign that a null pointer. Next, we'll run the query by passing in our query object. Now, at this point in time, after the query proximity function, our query will contain the number of entities, if any, were found inside of the proximity. We passed in the bounding box here. And then P entities will contain a list of entities. We can easily access that with P entities and then an index, 0, 1, 2, 3, etc., as you can see here. The entities function. Thank you very much. I hope you enjoyed, and we'll continue in the next task.